All right, everyone, welcome to our week 7 live classroom. Congrats, this is kind of like our halfway point in the class. So I hope you guys are excited about that. Pretty crazy, we're in June. But yeah, so welcome. And I hope that you guys are enjoying the week. Have any of you guys read through the book yet, through chapter 7?
I did.
I did.
Pretty fun stuff. I'm pretty excited about it. And we're going to cover everything in chapter 7 with chapter 6 and chapter 5, and it's going to be awesome. Well, before I dive into chapter 7, let's talk about last week. You guys had your debugging exercise and some desk checks, a lot of stuff. Do you guys have any questions about anything? Anything you want to go over or look at or practice before we go ahead?
Can you help me with debugging tools after this?
I sure can. You know what, I think maybe we're going to touch on a couple examples today during the classroom, but maybe after we go through the chapter 7 stuff, we can just have a little debugging session for anyone who wants.
Yeah, I can't get it to work, so.
Okay, yeah, that sounds great. Anything else you guys want to touch on today?
From last week?
Yeah, from last week.
No, okay. Nothing from last week. Thank you, though.
Okay, yeah. In that case, let's go ahead and dive into chapter 7. So this week is on logic. So these, let me present here, make this a little bit bigger. Shouldn't look super new. You guys have seen probably most of these already, but let's go ahead and review and learn them also. So these are the logical operators that are used in JavaScript. So last week I went through an example where I had an if-else statement and I isolated the ages between like 20 and 40, something like that. And I did that by saying if age is greater than 20 and with this little and operator if age is less than 40. Okay, so you can see in our template right here of this if statement, you can have a condition like age is greater than 20 and then have a logical operator to say another condition, okay? So you can have multiple conditions that could be the same variable, like age is less than 20 and age is less than 40, or they could be completely different variables, you know? We also talked last week about, you know, one of our examples, we talked about like male and female. You know, I could say if person is male and operator is less than 40, or if person is student and is greater than 18, whatever. You know, so with these operators, you can do pretty much anything you want. Okay, so this first one we have right here is the not operator. It basically makes a true value false. So for example, to say, you know, if a student was greater than like 20 years old, I could either say if age is greater than 20 or if age is not less than 20. I could use that like not operator. And that would basically like reverse it. And we can use those at any point. We have the and operator, which we've looked at. We have the inclusive or operator. So this one, what it basically does, so we have this template down here. We have two conditions. With the or operator, either one of them, if either one of them is true, then it will go into the if statement. If both will go into, so with the inclusive or, either one or both can be true, and then that if condition, the if statement will equate to true, and it will go into the if block of code. The exclusive or is similar but a little bit different, but it is only true if one and only one of the conditions is true. So in this case, if I had condition 1, exclusive or operator, condition 2, if both of them were true, it wouldn't go into the if block of code. It would have to be one or the other to be true in order for it to equate, for the Boolean value of the if to equate to true, and for it to go into the if block of code. Any questions about these before we look at some examples? Sweet. All right, so inclusive or example. So this program that I'm going to show you guys is a program that reads a girl's age from the keyboard and determines which class she should attend. Okay, so here's just like a little table for all the different ages that we're going to take into account in our little program here. Before we look at this, we could use an if statement with various else if blocks of code and then an else at the end. Or we could use a switch statement. Either one would be fine. But let's go ahead and look at this. So in here, I get the age from the user, okay, from an input with an ID. I look down here at the HTML. All I have is please enter your age, the input. I have a button to run my function, choose class, and then an output, okay, to place whatever class it is in there. I declared a variable called class, which I don't like, so I'm going to hit Control D and result class. So I have a variable called class, and then if I say if age is less than or equal to 11, do primary. If age is greater than 11 and less than 14, okay? And so right here, what's greater than 11 and less than 14, I've isolated ages 12 and 13. And so I put in comments right here, another way I could write this exact same piece of code is saying if age is equal to 12 or age is equal to 13, okay? And this would have the exact same outcome as this if we're dealing with whole numbers. And then here I also said if age is equal to 14 or age is equal to 15, then we'd go class would be myMade, and then if age is equal to 16 or 17, and then else, everything else we've covered less than 11, we've covered up through 17, so 18 and up would be release this ID. Okay, so I'm going to run this in my browser. So if I say 15, I might have broken my code here. All right, so let's look at what's going on here. So unexpected token class, renamed class is a reserved keyword. That's where I named it CLSS. So instead I'll name it we'll just leave it the way it was because class is a reserved keyword. Okay, let's try this again. 15, and it comes out myMade. Now, looking at this debugger, I said we go through a couple of examples today. I have my developer tools open. Again, if you right click on your page and hit inspect, or hit Control-Shift-L, I think that's an L, or hit F12, all of those will open up the developer tools. And then inside my function that I want to look at, choose class in this case, I'll just put a breakpoint on the first line of code inside of it. So right after this opening curly brace. Okay, now when I push this button, it comes into the class choose function because that's what the button called. And I can hit F10 to just kind of walk through here. I can see age came out to be 15. It was parsed properly. Oh, and it could never be a decimal. It'll always be a whole number because I used parse int. And then it'll just check, is age less than or equal to 11? No. Is it greater than 11 or less than 14? No. Is it 14 or 15? Yes. So it'll go into here, skip the rest, and then assign myMade to the output div. And that's it. Okay. Any questions about piece of code, the debugger, these relational operators? Any questions?
So do you usually put your breakpoint right after a function? Is that when you do it?
I do. Yeah, that's usually where I start. And then once I know that, you know, this code's good to go or this chunk of code is good to go, then I might move my breakpoint down just to kind of speed things up. Because if you know, lines 12 through 21 are functioning the way I intend them to, then I can move my breakpoint down a little bit so that every time I push the button, I don't have to like step through every little bit. But I just about always put it at the very top of the function,
Okay.
right side, just like right after the function header.
Okay.
Great question. Garrett, you raised a hand?
Yes, sir.
Go for it.
I'm just wondering about your first else if statement.
Yeah.
Because typically we, what we've had seen in classes, like you don't typically need the if someone puts in like, how do you say, between this age and this age, if you've already covered the ages between 11 and like 11 and under, it'll just, you know what I'm saying? Do you understand what I'm saying? I'm having a hard time explaining.
Yeah. So are you asking about like having like too many else if conditions? Is that what you're asking about?
Just it seems unnecessary to specify that the age be between 11 and 14 whenever you could just say if less than 14, because you already covered 11. Does that make sense?
Yep. You're totally right. And we could definitely do that. The reason why I did it like this for this was because I was showing you guys these logical operators.
Okay.
Yeah. So what Garrett was asking you guys, if I come over to my code right here, so we will go into this first if block of code if the age is 11 or less. So what he was saying is I should be able to just take this out and say if age is less than 14. Because 11 or less, if it's true, we'll go into here. But if it's not true, then it'll check this line of code. Okay, and so then it'll check to see if it's 12 or 13. So I could leave this as age is less than 14. I could leave this as age is less than 16. I could leave this as age is less than 18. And it would do the exact same thing that my code was doing before. Because it will only get to this line of code if each one of these was false. Okay. And then if it's not less than 18, then it'll go to my else statement. Is that that's what you're asking, Garrett?
Yes.
Yeah. Great thing to notice. Good job. All right. Any other questions or comments about this?
I have a question, not
Yeah.
about this.
Okay.
Is anybody else hearing you cut out? Because you're cutting out a little bit. I don't know if anybody else is hearing it. No? Okay, just me then.
No, once in a while he does.
Yeah, Emily, I wouldn't be surprised. Today, sadly, I don't have my headset. One of my girls or dogs ran off with it or something, and I have no idea where it is.
Okay, it's fine. I was just
I found
making
some
sure it wasn't.
headphones, but they weren't working very well, so I'm really sorry.
That's okay, you're fine.
Okay, Spencer asked, do you need to add an equal sign to the greater than and less than to compare instead of set the value? So Spencer, I believe you're talking about, let me put all this back real quick so we can see these beautiful signs. So right here, I think you're talking about the double equals versus the single equal signs, right? So if the double equals, I'll always want to put inside of these conditions, inside of the parentheses for the if statements, okay? The double equals operator is a comparison operator. It's not like this, that's an assignment operator. And so if, for example, let's say I put right here, if age equals 11, makes perfect sense in English, by the way, which is why people make this mistake. I'm going to type in 15 right here, and I can see age comes through as 15, which is right. And then all of a sudden age equals 11, and it comes into this, and it will always say primary because no matter what age I put in, right here on this first if statement, I will assign the value of 11 to age using the single equal sign, which is an assignment operator. This was a mistake that I talked about last week with our if statements and that I saw in final code submissions with people not being able to figure out why the code was working or people struggling throughout the week. Like, why isn't this working? I've spent hours trying to get this to work. And it's an easy mistake to make. And seeing the debugger like this, it's like, wow, like this helps. So learning how to use the debugger is extremely helpful. But yeah, so you never want a single equal sign or this assignment operator inside of the parentheses of an if statement because it will assign values to your variables and we don't want that. So, did that cover your question, Spencer? Same deal with the else if statements. For example, if I put right here, if age is equal to 14 or age is equal to 15, if the code got to this point, it would assign the value of 14 to age. And then this would be true. And if age was greater than 13, so it didn't come into these two, then it would always be MyMade because anything 14 and up would touch this and it would get assigned the age of 14 and then it would always come into this. line of code and skip these. So inside of your if statements, inside of else ifs, inside these parentheses, you never want assignment operators. What about the else? You have an equal sign on line 15. Yep, so that was my example. So if I undo this, this is less than or equal to. And so this is so you good, Spencer? That answer your question? Okay, awesome. Great question. Super good question. I'm glad you brought that up because I got a lot of questions about that one. All right, moving on to our next one. So Disneyland example. According to the Disneyland website, depending on when our book was written, guests wishing to drive a car on the Autopia must meet one of the following requirements. Either they're 54 inches or taller to drive alone, or they're 32 inches or taller and accompanied by a passenger 54 inches or taller. Okay, so we have to think about how we would put this into a program. Okay, how we would use these operators and how we would use if statements to basically see if a person can ride this ride. Okay, so here's a JavaScript program that accepts the height of a driver from the user. So if we think about our defining table, the input will be the height of the driver, or the height of the driver and the passenger that's accompanying them, and uses logical operators, inclusive or and to determine if they may ride the Autopia. Notice the use of parentheses in the if statement to ensure the logic is correct. The program outputs either enjoy the ride or sorry, to drive a car you must be this tall or so forth. Getting the question here, let's look at it real quick. If I type hard, my sound level drops a lot. Okay, so I'll try not to type. Okay, can you guys hear me okay? I feel bad that I don't have my headset today. Okay, you guys are laughing. Well, at least y'all are patient with me. Thank you guys. All right, height for Autopia. Okay, so let's check this out. We do have two inputs here. We have the driver and the passenger. We are parsing these inputs as whole numbers. That's what parse int does. We don't do decimals like the parse float does. Okay, so we're parsing these values. They'll come in as beautiful numbers that we can use these relational operators with. On line 20, I declared message. Didn't assign anything to it. We'll assign our message here in a sec, depending on which if statement this goes into. And let's look at this logic here. So the first option, if we look back at this, was the first bullet point. The driver himself, herself, itself, is 54 inches or taller. Okay, so our first if statement right here is the driver is 54 inches or taller. Okay, greater than or equal to 54. Or, and notice the second set of parentheses. Okay, this is kind of like in chapter 5 with all of our arithmetic, how we have parentheses to like separate, different chunks of math that we have to have executed together. Anytime I have a fraction with like variables underneath there that have to be like multiplied by something, I have to have that in parentheses in JavaScript to execute that math first, and then I'll do the division for the fraction. Similar to that, in that use of parentheses with math, we can do that with our if statements. Else if statements is always the same, okay? Anytime you can use stuff in an if statement, you can use it in an else if statement. All right, so in this case, I'll say either the driver is 54 inches or taller, or, and then this whole thing will be computed together. Or the driver is 32 inches or taller, and the passenger is 54 inches or taller. Okay, so I have two conditions here that are being checked for. One on the left side of this inclusive or right here, and one on the right side. And inside this right one, we have two little ones that are being checked for as well to get the whole thing to either be true or false. Okay, and if neither one of those inclusive or statements equates to true, then we'll dive into this else statement and assign this depressing message. Okay, so let's go ahead and run this code. Okay, so if I put the driver is 40 inches tall and the passenger is 55 inches tall. Let's put a breakpoint in here, just to make sure it's working. So again, first line of code inside my function. So after the function header. Okay, driver, what do we got? 40 inches, good. Passenger, 55, good. Message is undefined, but declared. All right, so now, let me show you guys something kind of cool that you can do. So right here, if I just hit F10, it'll jump down to line 22 or to line 24, depending on what equates to true or false. Okay? But I can highlight chunks of this to have my computer or the compiler kind of like execute it off the page to see what it will be, and I can look at it. So I can highlight from 54 all the way to driver, and it will say false, because driver is not greater than or equal to 54. Okay. Then I can highlight this chunk. Driver is greater than or equal to 32. That, in and of itself, is true. Okay. And then I can highlight this chunk. Passenger is greater than or equal to 54. Also true. All right. I can highlight this whole thing and see that that equates to true. Okay. So with this inclusive or, if I highlight over this entire thing, it will equate to true. You can see true popping up right here. Okay, because one of them did equate to true. The second chunk equated to true because the driver is greater than 32 and the passenger is greater than or equal to 54. So if I hit F10, it'll come into message equals enjoy the ride, and then jump down here and assign enjoy the ride. Down here. Okay. Any questions on this? Or any other scenarios you want me to walk through with the debugger running this? Okay, awesome. At least I hope it's awesome. Hopefully you guys can hear me. All right. Let's keep going here. So the exclusive OR. So I put this in here just as a little reference. These are the logical operators that we just went through, the not, and, inclusive, and exclusive ORs. So here is a small programming example from a program that includes buttons in its user interface. The code is used to enable or disable a button. Okay, this is an extremely common type of functionality in code. For example, let's say you have a website that has a little drop down. Okay, if my user was signing up for a service and they had to put their age, for example, I would have a drop down that would open up and have like maybe a list of ages that they could put, or something along those lines. Anytime I have a drop down. Okay, at some point in the code, if I'm using just plain vanilla JavaScript like we learned in this class, I would probably have code to say, if dropdown is open and they clicked on it, close it. If it's closed and they clicked on it, open it. Okay. Or if I'm using a JavaScript library, it's likely that that might be done for me. But at some point in the code, regardless of whether I have to write it or not, there's a place in the code where it's checking to see if it's open or if it's closed, and then to do the reverse, to toggle it. Okay. So this is extremely common, this type of mindset. Okay. So for this example, it's saying, if if something is enabled, and then the command, if they push the button to enable it. Okay. So if is enabled equals false, and the command is to enable it, obviously we would enable the button. If is enabled is true, and command equals disable, then we'll disable it. Okay. Now there's a lot of logic on here that we don't really need, because I could look at this exact same thing down below. I could say if is enabled equals true, or exclusive or the command equals enable, then we toggle the button. Otherwise we wouldn't. Okay, we would disable it. Okay, and this second one down here will handle both scenarios, whether we're enabling the button or disabling the button. Okay, because either one of them is going to be true, and regardless of which one it is, it'll just toggle the button. Another way to do it, right here, which is the exact same thing as both these other two examples, if an is enabled equals true, and if this chunk is not equal to whatever this equates to be. So if the command is enable, then it will never be equal to is enabled equals false. Okay, they'll always be opposites, and so with this negating operator, it will always toggle the button as well. So this is 3 different ways to toggle this button. Okay, for some people this might make more sense. For some people, this example down below might make the most sense. And hopefully for all of you, this one right here is the most confusing, but it's okay.
Can you scroll up a little? I can't see the bottom.
Yeah, so every time I move my mouse, this little Google thing pops up, but that's the bottom of the page right there. Let me see. At least I think it is. Let me come out of this real quick. Yeah, I'll add just a closing bracket right there, if you can see that better.
Okay.
Okay, any questions about this? All right, logical equivalences. Okay, so I made a little note here. This is a screenshot out of your book, and I say, don't memorize this, just kind of use it to practice. It's important to be familiar with it. Pretty sure the last time, at least I know the last time that I had touched on commutative, associative, and distributive laws was like decades ago. Okay, so don't stress about trying to memorize these. I'm never going to like ask you on an exam to like write this out. Okay, but it is important to kind of understand these principles, because if you understand these principles, then you can do the exact same thing that I did in the last slide, where I wrote out the exact same thing 3 different ways to produce the exact same result, depending on how I wanted to write it. Okay. But yeah, so this is just here for your reference. The one that I always get questions about is De Morgan's law. If you guys have any questions about the other ones, we can touch on those. So De Morgan's law, I guess real quick, do any of you have questions about those other ones before we just move on? Okay, sweet. If that changes, just let me know. So De Morgan's law, defined by Wikipedia, is a pair of transformation rules that are both valid rules of inference. The rules allow the expression of conjunctions and disjunctions purely in terms of each other via negation. I bolded that because that is like the crux of De Morgan's law. It all has to do with negation. Okay, so I could say if age is greater than 20, or I could say if age is, what was my example earlier? If age is not less than 21, okay? Those would both equate to the exact same thing using the law of negation, okay? So for this example right here, the dean of your college has asked you to write a program to print a list of students who are not on the dean's list for academic excellence. Okay, so this first example right here is if GPA is greater than 3.5 and credits is greater than or equal to 32. Okay, then they're on the dean's list. Or I could use negation to see who's not on the dean's list. And I could just like negate that entire thing. And I could pull out basically, you know, the exact same chunk of data using De Morgan's law, using negation. So anytime you hear De Morgan's law, just think about negation to like reverse something to produce a very similar output. Any questions about that? Did that help clear things up? Did that make sense? Never know whether to take your guys' silence as a good thing or a bad thing. Hopefully it made sense.
Well, one of the review questions, it shows it like you did there with the exclamation point in front of the whole statement, or then it also showed where you could put, for example, X is not equal to 7, or Y is less than or equal to 0. They flip the sign.
Yeah.
To make the same thing.
And so that sounds.
That was question 62.
Okay, was that in your book or in the review questions?
Review questions.
Okay. Do you want to look at that specific question? It sounds like.
I mean, if you just go over, it doesn't have to be that specific one, but so you could either put the exclamation point at the beginning of the entire chunk, or you can put it with the equal sign so it's not equal to, or flip the direction of the less than or
Yeah. So 2 examples. going off what you just said, yes, you can do either one as far as De Morgan's law is concerned. So if I like negated, let's say I shoved this whole thing in its own set of parentheses and I negated it.
Right.
So what's inside this if statement is just one massive thing that I just negated.
Right.
Okay. In which case, these messages would be swapped. Okay. That would just completely reverse the values. I just negated the entire thing using De Morgan's law. And that's what the outcome would be. Okay. The other example, like you said, the other one, like reverse comparison operators and so forth, was my example a second ago. And I won't use this just because there's a bit going on here that we don't want to have to worry about. So I said I had age declared. Let's go ahead and just assign like 20. And then in my if statement, I said if age is greater than 20. Okay. Now we can think about what all this would isolate. Okay. This would isolate everything 21 and up, right?
Mm-hmm.
And this would be the exact same thing as if I said if age is not, let's put it like this. If age is not less than, so if I could negate this entire thing, if age is greater than 20, and that would negate it as well. Or I could also say if age is not less than, or not, let's see, I'm getting hung up here. So if age is greater than 20, or if age is less than 21, would also have the same result. Not less than 21. There we go. Sorry, guys. So this would also isolate 21 and up. Okay. And so both of these, this example and my other one where I basically like negated this whole thing, used De Morgan's law to like produce the exact same output using the negation operator, using this little exclamation mark. Does that help answer your question?
Right. Yes. You just have to flip the direction of the operator.
Yeah. And I didn't want to use this example right here just because it's easier when you like take it like one chunk at a time. We could easily take this and be like, okay, this single condition driver is 54 or higher. Okay. So I could use a negation operator and say, if the age is not less than 54, kind of like I did right here. Where this one it said 54 and up, so I could say if driver is not less than 54, then that would isolate everything 54 and up again, and so that would be the exact same thing. And so for this, let's say I had a question on the review questions or an exam that wanted me to rewrite this, okay, using De Morgan's law. I would just take them one piece at a time, you guys. I'd say, okay, so driver, I need to have the same output, so I still need to go into this if condition if the driver is 54 or greater. So I would say either I would negate this chunk right here like that, or I would do what I just said and said is not less than 54 like that. Okay, and that would produce the same thing. And then I would do these ones as well, either negating the whole thing or switching around these. So this one says if driver is greater than or equal to 32, so it gets everything 32 and up, or is not less than 32. Okay, isn't anything less than 32, which would be the same. Okay. Does that help? Does that help, Lynette?
Yeah.
Okay. It's a little confusing. It's good to practice, which is why we have it. It's good to understand how it works, which is why we have it. But yeah, I did right here, just like writing out a little comment like, okay, what all does this encapsulate? And how could I reverse that? Okay, I want like everything greater than 20. I want everything that's not less than 20. Just kind of thinking through it like that. That helps.
Yeah.
All right. Any other questions?
Yeah, just on that quick question there. When you negate that, when you put a not, does that take out that whole, like all of when you put the not Oh, good crap. But the driver 54, would that exclude that whole thing? So it would go right past the or and go right into the parentheses of like driver is greater than or equal to 32 ampersand passenger. Is that?
Yeah, so I would want to use my debugger for sure. Okay. But where I put the parentheses right here, that was why I put the parentheses here. Because I didn't want this exclamation mark like getting in the way of anything else. Like I wanted it to negate this and this. And so if I have parentheses right here and then a separate operator afterwards, then it won't touch it. It will only touch what's right before the parentheses. But if I just like put it right here, it might be a little bit unpredictable. That's why I might want to put a breakpoint in there just to make sure that it's that I would want it to. Because let's say I just left it like this, and let's say I ran our program, still have it open right here. We have a nice little negation operator right here. Okay. I already know this stuff's working. So Lynette, you asked where to put a breakpoint, and here's my. I already know this stuff's working, so I'm taking this breakpoint off and I'm putting a breakpoint right here where I want to check. Okay, so let's just put that at 45 again, and this at 55, and I'm going to click that. Oh, unless there's an error in here. Is there an error? Oh, there we go. Okay, so the same way that I highlighted this earlier from the word driver to greater than or equal to 54, I can also highlight with the negation operator. Okay, and see what that does. And so for some reason right here, when I checked it without the negation operator, it said false. And then when I checked it with the negation operator, when I checked it with the negation operator, it also said false. Okay, so I'd come back in here and be like, okay, that's not going to work. So I'm going to throw this whole thing into parentheses. Okay, and then we give it another shot. Okay. So now that we have that in parentheses, let's try running that again. We have 45 and 55. Okay, and now let's see what happens. Okay, now this equates to true. Okay, the driver's height we know is 45. Is that greater than or equal to 54? No. Negated? Yes, the negation is true. Okay, so yeah, the debugger is super helpful for figuring out little things like that too, because you can like highlight things and see where they're at and how they're behaving. Okay, did that help answer your question?
Yep, thank you.
Okay, yeah, good question. All right, any other questions before we move on? Okay, sweet. All right, advanced word search. Okay, I love Google, just saying, you guys. So all these words. So for this search with Google, this is just, I don't know if you guys have ever done this, but searching Google, you can search for specific words or making sure to include specific words or having exact strings or excluding certain words or excluding certain websites, doing it by file type. If I wanted to find a PDF of something, there's a lot of different ways to search Google. And all of it down in the code looks exactly like what we've been doing today with relational operators and comparison operators and if statements, and that's exactly what it's doing in the background. Okay, so for this example, what are we looking at? We have all these words. Okay, so we have to have the word Madison in our results. And then it has to have any of these words, okay, county or parish, and then it cannot have the word Idaho. All right, so if I look at this in JavaScript, we have to have Madison. Okay, so we have Madison and then in here county or parish, but it has to be one of the two, and it can't be Idaho. Okay, so this says the exact same thing as this right here. Okay, and you guys will have a little exercise this week playing with Google search and thinking about how that would work programmatically. Okay, any questions about this? Okay, I will say it isn't every day that we'll be writing Google searches for programs in the professional world. However, it is extremely common to have a table of data that you have to sort or filter, and there will be very similar types of logic that have to go into that as well.
Brother Birch, I have a quick question.
Yeah, go for it, Emily.
Well, I was practicing with it. Mine is a little different on my Google search. I don't know, it's just not exactly the same as the picture that's in the book. And then some of the results that it pulled up did include words that I said not to include. So I don't know, maybe mine's not working or something.
Let's check it out. So let's do that example. We had Madison, this exact word or phrase, no, any of these words. We said parish or county, and then none of these words, Idaho. And if we search for that, okay. So you can see the first thing that came up was Madison Parish, Louisiana. And I don't see Idaho in here. And I'm not sure if it means, I would imagine that the word Idaho might exist on one of these pages. It might not. But at least like in like the header of the page or something like that, it should be there. Was this similar to what you were seeing?
Yes, but if I scrolled down and I did see it when I kept scrolling down. So you mean to just look at the stuff that's up on the top of the search then?
I mean, I don't know. I mean, theoretically, Google should be able to. Okay, so Idaho's not on this page. And again, like I said, maybe like if I went into one of these pages, there might be like.
Okay.
But yeah, so far, like I'm searching for Idaho on these pages. I'm getting to the 4th page. And it's not in any one of the pages so far. And I haven't like clicked on the page to see.
Okay.
But yeah, but I don't know. If I was doing it in a program, I would probably use like exact string comparisons. So like here, let me blow this up a little bit again. Here we're looking for this exact phrase with the quotes right here. And if I wanted to exclude something in a program like Idaho, like if I had a table that I was filtering and the user wanted everything that didn't have the word Idaho in it, then I would put a negation operator in front of this exact string of Idaho. But that's how I would do it, just to like cover my bases. Because if I have an exact string of Idaho and I say not that exact string, then I wouldn't pull it up. And again, like as far as data is concerned, there's a lot of different things that can be searched. I could be searching for text in the URL, or text in the header of the page, or text in the entire body of the page. Different things like that, or metadata on images on the page, And so depending, like if I was writing a website, if I had all that stuff coming up, then my JavaScript might not look this simple. I have to pass it through a function that would check for all of those different elements in the page. Okay. So depending on how Google does it, they might not check for metadata on images, or they might not check for something else. But
thank you.
Yeah, I hope that answered your question.
I was probably just doing it wrong, but I'll try again.
Okay. Let me know if you have questions after you do. All right. Any other questions on this?
Yeah, when we turn that in, do you want us to, like down here in your example, do you want us to show that, like interpret it into the, like the example of Madison County and that? Do you want us to? All right.
You don't have to. I think it'd be a good exercise if you'd like to, but you don't have to. Either send me a link with the URL of your advanced search that you did, or just take a screenshot similar to this one. So either way. All right, moving on. Second example of advanced search. All right, so this one has a little bit more going on. I don't think I'd be looking for a county in Louisiana, like a county outside of a specific county in the country that wasn't in Idaho, if I wanted to know if there were like duplicate names of that county or something like that. But I feel like this is pretty applicable to life, So in this example, wanting to find a small flatbed trailer to purchase in Southeast Idaho. Craigslist is what we're going to use. Instead, trailers are listed in the bikes, cars and trucks, farm and garden, motorcycle, and RVs categories. Okay, so it'd take a long time to look through these categories. So use Google to do the search and restrict it to search Craigslist and East Idaho. So we would want the words flatbed, trailer, not gooseneck, so we don't want a gooseneck trailer because I don't have anything that big. And the site has to be East Idaho in Craigslist where I'm at. Okay, I can do the same thing with Facebook Marketplace, with KSL, with finding a specific type of car or anything like that, and just searching Google for these things. Now, I wouldn't be able to type into Google this, but Google would handle this exactly the same as this JavaScript. Okay, requiring the words flatbed, trailer, not gooseneck, and from the site eastidaho.craigslist.org. Okay. So, any questions about this example? All right. This is pretty sweet stuff. There have been times where I wanted to find books in Portuguese or something like that to read to my children, and doing stuff like this has been extremely helpful. All right, truth tables. Truth tables are kind of intense. They're extremely helpful to work through things and see how things work in every scenario possible, but they can be kind of tough sometimes. So we create a truth table by considering 2 or more conditions. Okay, so let's have condition A and B. So our first condition is if GPA is greater than 3.5 and if balance is greater than 100, for example. Okay, with 2 conditions, there are 4 possible outcomes. Either both are true, either both are false, or A is true and B is false, or reversed, B is true and A is false. Those are 4 possibilities with 2 conditions. Okay, now as you can expect, if I have 3 conditions, that'll jump up. Okay, probably up to 9, probably just be 3 squared, and then 4 squared and so forth. Okay, so the more conditions there are, the more possible outcomes there are. So when we were looking at this program, in this example, I only wanted 2 possible outcomes. Either they can ride the ride or they can't. But let's say I had a program that would let people see what rides they were eligible for. Okay, and so instead of just checking the eligibility of a single ride, I might say, okay, you know, if their age is, or if their height is 50 inches or greater, and then if it's 54 inches or greater, let's also check to see if the passenger is over 70 inches tall for whatever reason. You know, because if I wanted to find different rides that would be suitable for this person or for these people, you know, I could have multiple things to check. And the more things there are to check, the more bases you kind of have to cover. So this example was pretty simple. I either said just basically true or false. Either they can ride it or they can't. But if for whatever reason, if I wanted to check to see if the passenger could ride something else, I would have to have more else if statements or more logic involved just to make sure that I would have every outcome that I would expect. So truth tables can be helpful for situations like this in both walking through your code to make sure that you have every scenario accounted for, and also just making sure that you're computing. So here's an example of a truth table with 2 conditions. Okay, so on the left here, we have A and B, and we said that there are 4 possible outcomes. So what I just said, either both are false, both are true, or one's false and one's true, and one is true. That right here, these 4 rows represent these 4 possible outcomes of A and B. Okay, and then here, I could also say in my truth table, if I negate A or negate B, what that would look like. So if A is negated and B is negated, then these would both be true. And for each column, I want to see what it would be. So if A is false, okay, and then I look over on this side right here. So is this false? False, that'd be true, and be true. And so anytime this is the opposite of column A right here, this first column, then it'll just be the opposite because I've negated A. Okay, same thing with B. When I negate B, this column will be the exact opposite of column 2. Okay, so when B is false, if I negate B in my program, it'll be true. If B is true and I negate B, it'll be false. Okay, A and B. Okay, so again, I want to see where A and B are true in these 4 scenarios. And there's only one, and it's that bottom one, when both are true. The rest will show false. When A or B is true. Okay, and so in that case, it would only be false on this first one when both of them are false. And the rest of them either either one is true or both of them are true, and all of these would be true. And this last one, the exclusive or, one of them has to be true, but they both can't be true, in which case only the middle two would be true. Okay, so does this kind of make sense how we're using these 4 scenarios that are available here and checking each one with these different operators?
I was having a hard time with this for a while this morning, but then I started to think about when you're using the, oh gosh, what's it called? And.
The ampersands or the and.
Yeah, that one. When you're using the and operator, then false wins if it's true, and false wins. And if you're using the or, what is it? The inclusive or, then true always wins. But I don't know if that's not a right way to think about it, if that will mess me up later.
It definitely works right now, and I think you're on the right track. And that's exactly the way that I think about it. You know, I look at this column 3, and it's like, okay, A is negated, so, you know, when will this be true? It's when A is false. You know, if A is false and I negate that, then it'll be true. And then I look at this and, you know, and like you said, A and B have to be true. So where are they true? It's, you know, so yeah, I think you're exactly right. And I think the more that you practice with these, and everyone I'm talking to, the more that you practice these and the more that you like look at these and like try to like work through them in your mind, the easier it'll be to like understand them. Okay.
Yeah.
So here's, oh, did somebody have a question?
I just said thank you.
Okay, yeah, of course. So here's another example. Given any 2 conditions, A and B, so again, look at the left side, it's the exact same thing, okay? We have those 4 scenarios for the 2 conditions. A and B, either both are false, both are true, or one and the other, or swapped, okay? And then we have these 3 different scenarios, these different operators that we're gonna work with and see how they look. Okay, so this first one, either A or B, and this is the inclusive or, so it's the exact same thing as column 6 right here. Okay, as long as one of them is true, at least one, then this will be true. Otherwise, when they're both false, this will be false. This will be false as well. Okay, this one, just a single ampersand, or double ampersand, I guess, but a single and operator, and it's checking to see, you know, if both of them were there, but it's not isolating these specific values. And so that's why these results are like that. And then this one, the not A, is the exact same as column 3 in example 7. Okay.
I have a question about that.
Yeah, go ahead, Lynette.
So, okay, in the example above, in column 5, it says it's comparing A and B, but in the example below, A and B in column 5 is not there. So it's comparing what happened in column 4.
Yeah, that's a great question. So this one right here, imagine if we just put a double and, so just like an and condition into like an if statement. Okay, all of these things we could think of as if they were like being used inside of an if statement. Okay, so whether I'm negating A or A and B, you know, you can imagine these like inside of an if statement. So in this second column 5 right here, we would never do this. Okay, because all it is just like this and operator with no variables, and so they would check, you know, like whatever was there previously, and basically it wouldn't give us what we would want because it could be unpredictable depending on what was in like the line of code previous to it or whatever was there prior to it, is what it would look at instead of you deciding explicitly like, hey, I want to see like A and B and see what would come of that. Does that make sense?
Mm-hmm.
Okay. Any other questions? All right. 2 conditions. So this is negated. Let's see here. A or B, we already saw that one. Not A, we already saw that one. And if both of them are true, and again, right here, depending on what was prior to it, you know, with this A and B, this would look for if in this case, both of them were false. And then not B, we already saw that one too. All right, and then we have this big old explanation right here. So we draw a truth table with a row for the headings and 4 rows for Boolean values, okay? Our 4 options for 2 conditions. Column 1 and 2, every combination. Columns 3 and 4, we translate the logical expression not A or B into JavaScript operators. So it would look like this in JavaScript, not, and then in parentheses, A or B. In which case, you know, A or B would be true, true, true for these 3, but we said not, and so it would just be true for that first one. In the heading row for columns 5, 6, and 7, we translate the logical expression, not A and not B into JavaScript operators, not A and not B. We're at the result of A or B in column 3, okay, result of not A or B in column 4, which finishes all the logic on the left side of the equivalency arrow, okay. And so it just kind of goes through it. And so in the book, it's really great because you can like walk through this and proceed and like see how these different things are playing out. And so if you're confused about any of these things, send me questions, yes, and ask me why things are the way they are or why something's not working. But also like go through these examples, you know, not just reading them, but also like interacting with them and really trying to figure out why they're functioning the way that they are. Okay. And any questions here or any column you want to look at or any questions about truth tables in general, anything?
And we have to be careful which column we do next because they're not in order. So
yeah, so like in this case with this little equivalency operator right here, you know, if I look at these examples right here, it talks about columns 3 and 4. We translate the logical expression not A or B. You know, we have the not individually and then A or B. And so these are being equated, like if I threw these together, like it shows here, not A or B, not A or B. That's what this column is right here. Okay, so we have this not, and A or B, and then we check those against not A and then not B. And so it does matter where these things are, where the equivalency operator is. And again, reading through these really helps to see how they're organized and kind of how you have to walk through them. Great question, Lynette. Did that answer the question?
mm-hmm.
Okay. Any other questions? Okay. Send them over. If you get them while you're reading your book and it's not clicking, just send them over. All right, common mistakes. We already talked about some of these with these if statements. So forgetting the left-hand assignment. So right here, I got a couple of emails about this actually. So right here, I can't just say if y is equal to 6 or 7. Makes perfect sense in English. But in JavaScript, we have to explicitly say if y is equal to 6 or y is equal to 7. Okay. If I put something like that into my code, I'm just going to say y is equal to 10. And I say y, what did it say? Y is equal to 6 or 7. Okay, ignore the rest of the program. We're just going to see which one of these blocks of code it goes into. Okay. So if I, where am I? There it is. Okay. So if I run this, I'll leave my breakpoint right here. 50, 40, check height. Okay, y is equal to 10. Y is equal to 10. And then is y equal to 6? No, that's false. Or 7. 7 is 7. 7 is just 7. Okay. So will that be true? Yes, because 7 is always 7. So this side of that or operator will equate to true because 7 is equal to 7. Okay. So that obviously didn't do what we wanted it to. So that's a very common mistake that happens. So you can't just say y is equal to 6 or 7. You have to say y is equal to 6 or y is equal to 7. All right.
Okay.
Same thing here. Each one of these, you have to this is the only correct way to do that type of logic. Okay, because again, this right here, 6 or 7, those will be computed independently. 6 is always equal to 6, 7 is always equal to 7, because that's what's on the other side. That's what's on these sides of this operator. Okay. Forgetting the and, this is a big deal. Some programming languages, you can do this. 10 is less than x is less than 20. Python's an example of one. But in JavaScript and many programming languages, you have to explicitly write it out. 10 is less than x and x is less than 20. Okay. Mm-hmm. And just for the record, this second one would also be completely valid in Python as well, or other programming languages that support something like this. Mixing up the logical operators. So this example right here, x is less than 10 or x is less than 20. This one will always be true, because if x is 10, that's less than 20. If x is 19, no matter what number you put in there, whole or otherwise, it will always be greater than 10 or less than 20. So in this example, we'd have 10 is less than x and x is less than 20. So that would make a big difference mixing up those operators. And again, I know I sound like a broken record bringing up the debugger again, but the debugger can really help. You know, if you can see a line of code and see what each chunk of these operators are actually computing, it can be really, really helpful in finding errors. Not just syntax errors that make the compiler throw off like red errors in the console, but logical errors that make your program not do what you want it to do. And then unnecessary comparisons. So who was it? It was Garrett. Garrett this morning brought up my age example with classes for girls, women in the church. My program had if age is less than or equal to 11, or if age is 12 or age is equal to 13. Instead, I could just say if it's less than 12, the next one, if it's less than 14, the next one, if it's less than 16, you know, like this. Okay. And again, this code would run fine. You just don't need it. And it's a little bit easier to see, easier to make less mistakes like this, easier to debug like this. And then again, mixing up the assignment operator and the comparison operator. Okay, like we talked about today. All right, any questions about common mistakes, any type of logic or selection or anything we've been working on?
I have one question.
Yeah, go for it.
Jumping back to the tables. So you said we can use this to check or walk through our code. Could you give us kind of an example of how you would create one while walking through the code?
Let's see here. So I might not do it like while I was actually like walking through my code, but I might use it to like help me write out code. So for example, if I put all that back to it. Okay. So if I had something like this, if I wanted to think about, you know, this driver is greater than 54 as like my A value, and this is my B value, you know, I could look at that and see what I would have to do if I would need like an OR operator or an AND operator or something similar to those, just to see how I would have to write that out in my if statement. So that is one example on how you could write that out. But like I said, I've never used it for like actually like walking through my code. I guess if something wasn't working the way that you intended it to, you could look back to a truth table and just check to see if it was behaving as expected, and if it's not, then to see why and what might need to change. But yeah.
Okay, thank you. That helps.
Yeah, you're welcome. All right. Any other questions? Okay. Well, we are going to stop talking about chapter 7 then. And as I promised Lynette earlier, let's go ahead and do a little bit of debugging. Okay. So anyone who wants to bounce, it's great. Anyone who wants to play with some debugging with us or debug a program of yours or anything like that, you are welcome to stay. I will keep recording for students who weren't able to make it today. So yeah, let's dive into this. Lynette, was there a specific program that you wanted to debug, or do you want to look at another one of mine?
it doesn't matter either way, but I'm realizing that when you're doing debugging, are you in edit mode?
No. No, I'm not. So let's pull up a program here. I'll just use the same program. Let me move over here. I'm just going to refresh the page. All right.
So it's read only, right?
Yes. Yeah. So right now I don't have anything open. I just hit refresh. I'm going to hit F12 to open up my developer tools. And I'm going to go over to the sources tab. Now, as you notice, there is an edit mode. And I can type in here and edit different things. And then I can run that code to see how it functions. Okay.
It is in edit mode?
No, sorry. So when I debug, it is not in edit mode.
Okay.
I'm saying there is an edit mode that you can use. And this edit mode is helpful when your code isn't easily executable. So let's say I work for General Motors, so I'll use them as an example. I used to make websites for manufacturing plants for people to use while they were like assembling cars or building pieces or painting or whatever, you know. And if a program broke in production is what we would call it when there was a website that was being used in production. It's being used by the plants, you know. If a program broke or didn't work, I could open up that website on my computer and run a common scenario, a scenario that they gave me, whatever broke it. And I could open up this and I could try to like fix the code in here. I could edit this and make it work for that scenario and make sure that it's working for other scenarios. And I'd be like, okay, that's what I have to change. And then I would just like send that change up to the line so it would be in production for them. You know, so that's one example of why I might want to edit this inside of the developer tools. For us, where we have this right here, and all we have to do is hit Control S and refresh the page in the browser, that we will never really have a purpose to edit it in here. Okay, so that's what the editing is for. If you want to edit a live website to see what's going on, or to try to debug a live website. Okay. So we aren't in the edit. This is in the read-only state. I can't edit this right now. And this isn't in the Elements tab. I can see my code right here. And this confuses a lot of people because I can see my code right here, but there's no way to put a breakpoint right here. Yeah, okay. So we're in the Sources tab. And then in here, I can just click on the line number and put a breakpoint.
Okay, the problem I have is that I'm able to put a breakpoint in, but it doesn't run. I like the play button or the jump button, whatever they're called. Those different buttons, they're all grayed out. So I don't know how to make it work.
All right, let's look at mine. They're grayed out like this? Let me see if I can change this. Settings, appearance, light. Is this what your developer tools look like?
Oh, I'm trying to move this because it's blocking my view here.
I don't know if you guys noticed, but my thing blocks my view like all the time. And I'll be like teaching our classes and it's in the way like all the time.
Yeah. It's grayed out. I can't really see because there's a bar over it, but
Okay. So I'm trying to replicate what I think you're seeing. So if you look at my screen, hopefully this looks very similar to what yours looks like. And if I look at these 4 buttons over here, they're all grayed out and I can't click on them.
okay, right. Yes.
Okay. And that's because my function isn't executing. These all become interactive once I am debugging. So I have a breakpoint here, which is an essential first step. But I need to run this function for the debugger to actually like kind of kick off. Okay. So once I click this button, I went into this function and the debugger started, and all of a sudden these buttons aren't grayed out and I can click on them.
Oh, okay.
See that?
That's all it is? You just have to click the
That's
button
it.
on the left?
Yep. Because in my example, you just have to call the function check height, or whatever function you have, whatever function you want to debug, you just have to call it. So in this code, my button calls check height. And so as soon as I click the button, it'll jump to this code and it'll execute this code and it'll stop wherever I put the breakpoint.
Okay.
Yeah. Great question. It's always a little.
All right.
All right. Any other questions?
That must have been what I was doing wrong.
It's all good. Gotta learn sometime. All right. No other questions about debugging? Anyone want to debug a piece of code they have?
I did have another question. I saw you at one point put in like 5 lines of code really fast, like you just copied it 4 in a row or something like that. It's like, how did he do that?
All right. I love Sublime. I love text editors in general, but okay. So let's say I have my template program, okay? I have my little template function that takes a single user input, does a little bit of whatever, and then I have an output. Okay, so this is my template function where I have an input and processing and an output, and so I have everything like in its place ready to go. And if I click on this button, it'll run this function and so forth. So let's say I take this template function and I'm going to save it as just test. That sounds great. Okay, so let's say I was starting a new assignment, and in this assignment, the user, for whatever reason, had 4 inputs. You know, let's say I wanted the user to type in their name, their favorite color, their birthday, and whatever, okay? And I had multiple inputs. So if I hit Control-C, copy, Control-C, I don't have anything highlighted. I'm just on this single line of code.
Mm-hmm.
Cursor's blinking right here, and I hit Control-C. Just now I copied this entire line of code. So if I hit Control-V,
Oh,
it'll just paste that line of code.
okay.
When I hit Control-C, it copied this.
Okay.
With the line break, this entire line of code, it copied it. So when I paste it, it'll just paste it again. And again and again and again. Okay? And
So you hit Control-B each time?
Control-V, as in Victor.
Oh, Control-V.
Yeah, to paste. Yep. And here's a fun little trick for you guys. This is something that I do frequently. I mean, anytime there's a case for it. So I have a new spreadsheet here, and you can do this just with Excel too. I just don't pay for Excel anymore. So let's say I have a spreadsheet here. Come on, little guy, you can do it. Okay. So I type in 1, 2. I can highlight these, drag this thing down, and get a big old numbered list. Okay.
Mm-hmm.
And I have, let's say I undo that, and I want like 10 lines of code right here, like 10 different inputs. So I have 2, 3, 4, 5, 6, 7, 8, 9, 10. Just pasted that, hit Control-V every time. And then in here, I could highlight 10 of these, copy them, paste it over here. If I hit Control-A and Control-Shift-L, I'll make a new line on every one of these. And I can copy it, come over here. And then in here, I can highlight this, hit Control-D to highlight them all, and then move my arrows around to move my cursor. I can just backspace there and paste. And they'll all have their own like unique ID. Okay, so anytime I had to like, there'd be times where I'd have to put like a unique ID on every element in an HTML document that's like thousands of lines of code. I would just like basically do that with like a bunch of them, you know? So anyways, that's just a little thing that I like to do sometimes. But
What is Control-D?
Control-D is to highlight the next instance of something that you have selected. So just now, I have this ID temp1 a bunch of times over. But like, let's say I just wanted to like highlight this ID. I can just take Control-D, and it makes a separate cursor for every line. And then I can like move my cursor around and I can type in each one of those spots at the same time. Or in my case, I can paste the 10 unique IDs that I had on the other page that I pulled over from Google Sheets or Excel and just paste them in.
Wow.
Yeah. You don't have to know that for this class. I'm just showing you. But I think I touched on that in my. I made a hotkey video. I forgot who requested it, but let's see here. Videos.
You made a hotkey video?
Sure did. All right. Let's see here once this thing loads. Sublime hotkeys. Right here. And I didn't make a little list in Excel and paste that like I just did, but I did go over the Control-Shift-L to make a line on every selected line, or to make a cursor on every selected line. Control-D to select the next instance of a string that you highlighted. Control-D, that's how in this, where this was named CLSS, and I'm like, that doesn't make sense. I hit Control-D to highlight every instance of CLSS. I'm like, I'm going to rename that to class.
Wow.
But that class was a reserved keyword, so. CLSS. So that was Control-D also. All right. So yeah, to make a bunch of lines of code, if you just like copy a single one and hit Control Paste or Control V, just over and over, it'll just paste it as many times as you want. My long answer to your simple question. Any other questions?
Is there any way to download these videos that you do to our computer?
Yes. Let me think. So I upload them to YouTube. Okay, so I mean, I know that there are like YouTube downloaders that you can like look up. Like if you type in like YouTube video downloader, like it's just like an online thing, and you can like paste in the URL of a video, and I'm fine if you want to download my videos. I'm not sure if that's entirely legal for a lot of stuff, but I'm fine if you want to download my stuff. Outside of that, I'm trying to think, because I just store them on YouTube. But yeah, I mean, for my videos, you can just find a YouTube downloader online and then just paste in the URL to download my videos, and I'd be just fine with that.
Okay.
Sorry, there's not a better way. I don't have them stored anywhere else. All right. Any other questions, you guys? Okay. Well, if you ever need practice debugging stuff or something's not clicking, just let me know. But yeah, week 7, hang in there and let me know if I can help you with anything.
Okay, sounds good. Thank you for
Hey,
going over that.
of course. And thank you all for joining me. I hope you guys have a great day.
All right.
Thank you.
Yep. Thank you guys. Bye-bye.